Hello again, my name is Angelica, and I am presenting laboratory exercise 4, which demonstrates the difference between static and dynamic scooping in Perl. So I've written a simple program here that clearly shows how these two scooping mechanisms work differently. And let me walk you through the code line by line, then I'll run it and answer the required questions. And I am just using a Perl compiler here. So let me explain the code from top to bottom. In lines 1 to 3, line 1, this is a shebang line that tells that this is a Perl script. Then I am using use strict to enforce variable declarations and helps catch errors at compile time. Then in line 3, I used warnings to display warning about potential problems in the code. And these are standard best practices for Perl programming. So let's move on to line 5 to 7 as the header. So this is just a print header for the output. The equal sign times 50 that will create a line of 50 equal sign just for decoration. So now we get to the first demonstration. Let's talk about the static scooping using my keyword. So in line 12 to 13, these these lines print the section header. And in line 15, my $x is equals to global. This is very important. I am creating a variable called $x using the my keyword. And the my keyword creates what's called a lexical variable. And this means that the variable is scoped to the block where it's declared. And in this case, $x equals the string global. This variable uses a static scoping, and which means its scope is determined at compile time based on where it appears in the code. So line 17 to 19, here I define a subroutine called show underscore x, and all it does is just print the value of $x. The key question is which $x will it see? Or will it see a global one? Or will it see a local one from whatever function calls it? Because because of this static scoping, this function will only see the $x visible in its lexical scope, meaning the $x from line 15 here, which is global, it cannot see local variables from functions that call it. So let's move on to line 21 to 25. Now, this is where it gets interesting. The subroutine test static here creates its own variable called $x using my and sets it to local. Okay? So now we have two different variables, both named $x. The outer one from line 15 that equals global, and the inner one on line here 22 that equals local. In line 23, the value of $x within this function, it will print local. But then in line 24, I call show underscore x. So here is the critical point. Show underscore x will not see this local $x. It will see the outer $x from line 15. Why? It is because my creates lexical or static scoping. So the scope is determined by the code structure, not by the runtime code chain. And show underscore x looks for $x in its own scope and in closing scope based on the code structure, not based on who called it. So in line 27 to 29, these lines execute the demonstration that we print $x from main and we will call test static. Then we will print $x again. And you will see that the outer $x never changes. That's for static scooping. Now let's move on to dynamic scooping. So in dynamic scooping, using the local keyword, this is very different. So just print the section header for part 2. Then in line 37, okay, you notice that I am using our here, not my. So the our keyword creates a package variable. And this is important because local only works on package variables, not lexical variables. So $y here equals global, and it's a package variable that's globally accessible. So that in line 39 to 41, this subroutine is similar to show underscore x. Had you remember that it just prints the value of $y. But this time, because we are using dynamic scooping with local, this function will see modifications made by its caller. So, here. So, in line 43 to 47, this one. Here is why dynamic scoping happens. In line 44, this one, local, not my, to temporarily change $y to local. And the local keyword does something special here. First, it saves the current value of $y. Then it changed $y to local. And then this change is visible to all functions called from here. And when this subroutine ends, the $y automatically goes back to its original value. So on line 46, show underscore y, it will see local because local creates dynamic scoping. The binding is determined at runtime based on the code chain, not compile time based on the code structure. So, after line 47, when this subroutine ends, $y automatically gets stored to global. Okay? So, in line 49 to 51, we execute the dynamic scooping demonstration and see that $y is automatically restored. Okay? So, in line 54 to 57, we just finally print a summary showing that the key differences between the two up to here, just for um, X, like what we did in the beginning for a borderline. Now, let me run the program to show you the actual output. Okay, so this is the output of our code. In part one, when test static is running, test static has here, test static has $x equals to local, but show underscore x sees $x equals global. So the call function did not see the color's local variable. Okay? While in part two, the dynamic scoping, when test dynamic is running, the test dynamic has $y equals to local. And show underscore y sees that the $y equals to local. And the code function did see the color's modified value. And notice that after both function finished, the main scope still has the original values. Nothing was permanently changed. So, in classic dynamic scoping, when a function reference a variable, the system searches backward through the runtime call stack, meaning it looks at which function are currently active and executing, and it finds the most recent binding of what variable name in the call chain. And this is pure dynamic scoping that it's completely based on the execution flow at runtime. If function A calls function B and B calls function C, then C can access variables from both A and B by searching back through the active call stack. To wrap up, my create static or the lexical scoping scope determined by code structure at compile time. And local creates dynamic like scooping called functions see temporarily modifications. But Perl's local is not pure dynamic scooping. It's a save and restore mechanism for package variables. So this demonstration clearly shows that the difference between these two scoping mechanisms. Thank you for watching.